Hello. So in this video, we are going to look at infinite geometric series examples. So what is an infinite series? Well, it's a series that has no end. So it's a non-ending series. It goes on forever. Now there are two types of series. We have a converging and a diverging. And specifically in this video, we are going to be talking about a converging series. And I'll just highlight this in red, underline it in red. So this is the condition for convergence to occur. We say a series is converging, that is a geometric series. We say it's converging if R, which is your constant ratio, is between -1 and 1. It is also interesting to remember that when you are talking about values between -1 and 1, you are talking about fractions, and that is very important to remember. So looking at this formula, this is the formula that we use to calculate the sum to n terms for a geometric series. Now let us look at this particular term, r to the power n. Now given that we have a fraction, let's say 1/2, if it is raised to power 2, well, that will give us 1/4. If we have the same fraction 1/2 raised to power 3, we get 1/8. So what we notice is that as this continues, the fractions get smaller and smaller. So in other words, as n approaches infinity, in other words, as this n is getting bigger and bigger, the value of r to the power n approaches 0. In other words, it gets smaller and smaller. Now it gets so small that the sum to infinity can be written as a over 1 minus r, because if r to the power n is 0, then we are just left with a multiplied by 1, which will give us a. So this is the formula that we use to calculate the sum to infinity, and fortunately it is also there in your formula sheets. Now let us look at a few examples. So firstly, we are given 1/3 plus 1/9 plus 1/27 plus 1/81. So this is a series, and this ... indicates that it goes on forever. Now we need to find our constant ratio, because we know whenever you are asked to find the sum to infinity, that is a geometric series. So 1/9 divided by 1/3, that will give you 1/3. This will also give you 1/3 and 1/3. So that tells you the value of r. So a, which is our first term, is 1/3, and r is 1/3. So if we calculate the sum to infinity, it's a over 1 minus r. A is 1/3 over 1 minus 1/3. So if you put this in your calculator, you are going to get 1/2. So the sum to infinity will be 1/2. Looking at the second example, there's a point that I like about this example, and it goes here. So if you look here, you have a negative, and here you have a negative. So sometimes learners will think this cannot be a series because a series should have a plus. But in reality, a plus and a minus always go together. And a minus, this series could have been written as 2 plus minus 4 over 3 plus 8 over 9. Now we know that positive times negative will give us negative. So even if we have a minus, it is still a series. Now let us get our constant ratio. Minus 4 over 3 divided by 2, that will give us minus 2 over 3. And as well, 8 over 9 divided by minus 4 over 3 will give us minus 2 over 3. So that means the value of A is 2, the value of R is minus 2 over 3. So the sum to infinity, A over 1 minus R. So A is minus 2. No, sorry. So let's go back. So A is 2, 1 minus 2 over 3. It's very important to remember this minus. So it's wise to put in your bracket or your parenthesis so that you remember that you have two minuses, which would be a plus. So if you plug this in your calculator, you will get a value of 6 over 5. So example 3. So now in this example, it's a little bit different from the previous two examples. In this particular case, you have a series that has unknowns. So you can see the first term is 3x, second term is 3x into x minus 2. So there's an unknown. So let us see. The first question says, for what values of x will the series converge? Now, if you remember when we were introducing this part, we said a series converges when r is between minus 1 and 1. So that is a condition for convergence. So when you answer such a question, you write your condition for convergence and then you substitute the value of r. Now let us find the value of r. To get the value of r, it's term 2 minus term 1. So what is term 2? It's 3x into x minus 2 all over 3x. Now, this 3x will divide this 3x. So we are left with a value of r of x minus 2. So it means our r is x minus 2. Now, we are not asked to solve for x minus 2. We are asked to solve for x. So, we need to say minus 1 x minus 2, 1. So, I can show you like this. In order to get rid of this 2, we must add a 2. So, it will be minus 2 plus 2, which is 0. And we are left with just x. So because we added 2 here, we must also add 2 here, and we must also add 2 here. So finally, we are going to have x greater than 1 but less than 3. The second question says, if x is 3 over 2, calculate the sum to infinity. So now they are giving us the value of x. So they are saying that x is 3 over 2. And if you remember, in our calculation, we had calculated r to be x minus 2. So this would be 3 over 2 minus 2. Remember, 3 over 2 is 1.5. So if you minus 2 there, it would be minus a half. Sum to infinity is a over 1 minus r. A, which is the first term. So if you go back here and substitute, so you have 3x. So that would be 3 into, we said x is 3 over 2, so this would be 9 over 2. So if you go back and substitute that, so you'll have 9 over 2 for your a, 1 minus your r will be minus 1/2. Putting this in your calculator will give you 3.